Dear students, grade 11, hope you are doing well. For today we are going to finish chapter 5 section 2. Chapter 5 section 2, when we derived the ideal gas law. The ideal gas law, for today we use the ideal gas law to find molar mass or density, or we can say finding molar mass or density from the ideal gas law. Finding molar mass or density from the ideal gas law. Finding molar mass or density from the ideal gas law. Suppose that the pressure, volume, temperature, and mass are known for a gas sample. You can calculate the number of moles in the sample by using the ideal gas law. Then you can calculate the molar mass by gram per mole by dividing the known mass by the number of moles. An equation showing the relationship between density, pressure, temperature, and molar mass can be derived from the ideal gas law. The number of moles N small is equal to mass divided by molar mass. Substituting M divided by M capital, M small mass, M capital is molar mass for N into PV is equal nRT, gives the following equation. PV equal mRT over M. P pressure, V volume, M small mass of the sample, R gas constant, T temperature in Kelvin, M capital is molar mass, or M capital equal mRT divided by PV. Density, also we can find the density in mass. Density is mass M small per unit of volume. Density equal mass divided by volume. By writing this definition in the form of the equation, the definition of density gives the following equation. D is equal M divided by V. D is density, D capital, M mass, V volume. You can see that M over V appears in the right hand equation above equation, or in the previous slide. M over V is equal D, density. Introducing the density into the equation gives the following. M is equal mRT over PV. M over V is equal density. Then we can substitute it M over V by density D. The equation became like this. M is equal dRT over P. The solving for density gives the following equation. D is equal MP over RT. You can see that density varies directly with molar mass. The density varies directly with molar mass and pressure, and inversely with Kelvin temperature. Then we can say the R capital is constant. This is fixed, but density directly proportional with molar mass and pressure, but inversely proportional with temperature, Kelvin temperature. Now let's resolve some question. Let's restart with practice. Now let's resolve some practice about how we can use the ideal gas law for finding the molar mass or density for any question sample. For question number 1, what is the molar mass of a gas if 0.427 gram? This is the mass because the unit is gram of the gas occupies a volume of 125 milliliter at 20 Celsius degree and the pressure 0.980 atm. Now, how we solve this type of question? At first, you must know the noun and unknown in the question. What is the molar mass? Then a noun is molar mass. Noun, given mass. We have mass and volume and temperature in Celsius degree and pressure in atm. At first, you must convert this Celsius degree to Kelvin temperature. Convert the temperature in Celsius degree to Kelvin temperature. We have a relation. Kelvin temperature is equal Celsius degree plus 273. The answer is 293 Kelvin. Then convert the unit of volume, the volume in milliliter to liter. Milliliter to liter, because in the equation molar mass is equal mRT over PV. R is standard constant or standard, which is equal the unit of R is equal Kelvin atm. You must convert it. We must convert it the volume in milliliter to liter. We divided the milliliter by 1000, which is equal 125 divided by 1000 equal 0.125 from 1000 liter. Then we substitute m small, which is indicate mass. R is gas constant, T temperature in Kelvin, P pressure, volume, V in liter. M is 0.427. This is mass given in the question, and the gas constant 0.082 multiplying by Kelvin temperature, which is equal to 193 Kelvin, divided by P pressure 0.980 times 0.125 125.125 liter. Then after multiplying these these numbers, the above is equal, the algebraic sum for them by multiplying these numbers is equal 10.26 divided by 0.1225. The answer, final answer, will be molar mass equal 83.755 gram per mole. Gram per mole, this is the unit of molar mass. This is the unit of molar mass, and this is the molar mass of this gas. Let's resolve another question. What is the density of sample of ammonia? Ammonia gas, NH3, the chemical formula for ammonia gas, NH3. If the pressure equal 0.928 atm atmospheric pressure and the temperature is 63.0 Celsius degree. At first, you must convert the Celsius degree to Kelvin temperature, Celsius degree to Kelvin temperature by using the relation Kelvin is equal Celsius degree plus 273. Celsius degree 63 plus 273, which equal 336 Kelvin. 336 Kelvin. And the molar mass of ammonia. Why we find the molar mass? Because the density, needed density. The question asks about density. Density is equal mp over RT. M molar mass. How we find molar mass? We do not have molar mass. The atomic mass for nitrogen is 14, and for hydrogen is equal to 1. Then the molar mass, we learn this, how we find the molar mass. Molar mass is equal 17 gram per moles. 17 gram per mole. Density is equal mp over RT. M, we say M capital is molar mass, P is pressure, R constant, gas constant, T Kelvin temperature. Then density is equal 17 multiplying by the pressure 0.982 982 divided by the gas constant 0.082 multiplying by 336 Kelvin temperature. After multiplying this number, we get the following. Density is equal 15.776 divided by 85,386, and the answer will be density is equal 0.185 gram per liter. The unit of density, gram per liter. Let's resolve another question. The needed density. Density of gas found to be 2 gram per liter at 1.50 atm and 26 Celsius degree. What is the molar mass of gas? Here needed molar mass. Wanted to find the molar mass of gas. How we find the molar mass of gas? The molar mass at first always must be convert the Celsius degree temperature in Celsius degree to Kelvin temperature, to Kelvin temperature. Kelvin 27 plus 273 equal 300 Kelvin. 300 Kelvin. How we find the molar mass? Molar mass, M is equal dRT over P. dRT over P. Why we use this relation? Because in the question given the density R, we know T temperature in Kelvin, and P given in the question. Okay, now molar mass is equal D density 2 gram per liter and R 0.082 multiplying by 300 divided by 1.5, and M is equal 49.2 divided by 1.5. The final answer is 32.8 gram per mole. 32.8 gram per mole. Let's resolve another question. What is the density of argon gas at pressure of 551 torr and a temperature of 25 Celsius degree? If the pressure is not in atm in the question, you must convert it to atm, and if the temperature is not in Kelvin, you must convert it to Kelvin temperature. Let's so how we convert pressure in torr, given in torr in the question, to atm. Pressure in atm is equal pressure in torr given in the question divided by 760 and the answer will be 725 atm by dividing the 551 divided by 760, and the answer will be 0.725 atm. And then we must convert the temperature in Celsius degree to temperature in Kelvin, because this is a standard. 25 Celsius degree given in the question plus 273, the answer 298 Kelvin. 298 Kelvin. Then needed the molar mass because the relation D needed density is equal MP over RT. M molar mass of which gas? Gas in the question is argon gas. The molar mass of argon gas given in the question is equal 39.95 gram per mole. Then we substituted MP divided by RT. We substituted M by the number of molar mass 39.95 multiplying by P. P is equal 0.725 atm divided by R. R is equal 0.082 multiplying by temperature in Kelvin 298. The answer density is equal 28.96 divided by 24.44. Then we get the final answer. The density of the argon gas, the gas which is argon given in the question, is equal 1.185 gram per liter, or 1.185 gram per liter. By this we finished this section. Hope have a nice time, guys.